Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 8.4, surface area and volume of similar solids. And it can be found on pages 356 to 358. Okay, so let's talk about some nuts and bolts that are going to make life a little bit easier. When we're talking about similar, think equivalent fractions. It's going to make life easier. So when we're talking about similar, think equivalent fractions. And we need to compare like units. So what that means is we need to compare inches to inches, meters squared to meters squared, feet cubed to feet cubed. We may not compare inches to inches squared. That's a big no-no. We may not compare feet to feet cubed. We need to make sure that we have like units. Okay? So let's get to it. Okie doke. The book gives us a cylinder that looks like this. Cylinder A. They give us cylinder B that looks like this. And then they give us cylinder C that looks like this. Cylinder A has a radius of 6 meters and a height of 4 meters. Cylinder B has a radius of 5 meters and a height of 3 meters. And then cylinder C has a radius of 7.5 meters and a height of 5 meters. And the book wants us to find which two cylinders are similar. Which two cylinders are similar? Okay, well, I know similar means equivalent fractions. So which two cylinders make equivalent fractions? Well, let's start with, let's put cylinder A over cylinder B. And let's work with what we know. Let's work with the radius. So the radius of A is 6 over the radius of B. And then let's work with the height. The height of cylinder A is 4 meters, and the height of cylinder B is 3 meters. So we're dealing with meters. We have like units. Now, if these are similar solids, they should create equivalent fractions. Okay, to test equivalent fractions, we cross multiply. So we have 6 times 3 should be equal to 5 times 4. 6 times 3 is 18. 5 times 4 is 20. Whoa! 18 does not equal 20. This is not a true statement. Therefore, A and B are not similar. So A and B are not similar. Okay, let's try our luck with A and C. Once again, I'm going to put A over C. I'm going to put A over C. And let's take a look at the radius. Well, the radius of A is 6, and the radius of C is 7.5. Now let's take a look at the height. The height of A is 4 meters. Don't forget to put your units. And the height of C is 5 meters. Now, if these are similar solids, they should create equivalent fractions. So to test equivalent fractions, 6 times 5 should equal 7.5 times 4. 6 times 5 is 30. 7.5 times 4 is 30. Oh, look at that. This is a true statement. Therefore, A and C are similar. So we've done this before. All we're doing is setting up ratios. 6 to 5 should be equal to 4 to 3 if they're similar. And in this case, they are not equivalent fractions. It's not true. Here, 6 to 7, the ratio of 6 to 7.5 is equivalent to the ratio 4 over 5. Therefore, they create equivalent fractions, and they are similar solids. Okay. So let's take a look at another one. We can use the idea of similarity and equivalent fractions to find missing measurements. So the book gives us cone A. This is cone A. We have a radius of 5 yards and a slant height of 13 yards. Then they give us cone B. Cone B has a radius of 7 yards and a slant height of X. And they're telling us that cone A and cone B are similar. They are similar. Great. So we can use this idea of equivalent fractions to find a missing measurement. So I'm going to put cone A over cone B, and I'm going to deal with what I know first. I know my radius, or radii. The radius of A is 5 yards, and the radius of B is 7 yards. Now let's deal with our slant height. The slant height of A is 13 yards, and the slant height of B is X. Now, because they're similar, they are equivalent fractions. Okay, because they're similar, they're equivalent fractions. So we can cross multiply. 5x is equal to 7 times 13. So 5x is equal to 91. I need to isolate my variable, so I'm going to divide by 5. What I do to one side, I must do to the other. X is equal to 18.2 yards. So my slant height is equal to 18.2 yards. So we can use the idea of similarity, creating equivalent fractions to find a missing measurement. Okay. Okay. Let's do yet another example. Okay. Okie doke. So the book gives us a pyramid that looks like this, pyramid A. Then they give us pyramid B. So we have pyramid A and pyramid B. Now, pyramid A, they give us a height of 6 feet. Pyramid B, they give us a height of 10 feet. And they give us a surface area of 600 feet squared. And we need to figure out what the surface area of A is. And they're telling us pyramid A is similar to pyramid B. So these are similar pyramids. They will create equivalent fractions. We have our known heights and we have to find the surface area. Okay, we can totally handle this. So I'm gonna put pyramid A over pyramid B. And I'm gonna deal with what I know first. I know the height. So the height of A is 6 feet and the height of B is 10 feet. Now let's work with surface area. The surface area of A is X and the surface area of B is 600 feet squared. Now, because they're similar, we have set up equivalent fractions. But we kind of have a problem. We're trying to compare feet with feet squared. This is where I was talking about we need like units. 10 feet is a line. Feet squared is a square. A line is not equal to a square. So we cannot say these are equivalent fractions because a line is not equal to a square. So somehow we need to have like units. We need to change this to feet squared. We can do that. We're going to square this. So over here, what that means is 6 times 6 over 10 times 10, and this is going to now be feet squared, okay? So this is what's going on. We're squaring this. This is what's happening. So 6 times 6 is 36. So we have 36 feet squared. 10 times 10 is 100 feet squared. X over 600 feet squared. Now we have like units. Now we have feet squared and feet squared. Now I can cross multiply. So this is 36 times 600 should be equal to 100x. So 21,600 feet squared is equal to 100x feet squared. I want to isolate my variable. So I'm going to divide this side by 100. What I do to one side, I must do to the other. So 216 feet squared is equal to x. So the surface area of pyramid A is equal to 216 feet squared. So we're still using the idea of equivalent fractions to finding a missing measurement, but before we do that, we have to make sure that we have like units, okay? So I had feet and I had feet squared. I had to square this term right here so that I had like units. Okay, let's do one more. Let's do one more. Okay, SeaWorld has a touch tank. Their original touch tank looked like this. This is the original touch tank, and it held a volume of 2,000 cubic feet of water. So this is SeaWorld's original touch tank. They decide they want to build a new touch tank and they want to double the dimensions. So we're doubling the height, we're doubling the length, and we're doubling the width. So this is the new touch tank. And all we know is that it's been doubled. We don't know what the original dimensions are, but we know that it's been doubled. So what we are using is a ratio. If this is 1 foot, we've doubled it to 2 feet. If this is 15 feet, we've doubled it to 30 feet. If this is 50 feet, we've doubled it to 100 feet. It doesn't matter what the exact measurement is, as long as we know the ratio. The ratio is 1 to 2. We're doubling it. Okay, we need to find out what the volume is of the new tank. How much water are we going to need to fill the new touch tank? So we're going to set this up exactly like we've done. They are similar solids. So I'm going to set up the original over the new. And I don't know exactly what the dimensions are, but I do know the ratio, 1 to 2. We are doubling the original dimensions. And I'm going to use this to find the volume. So I have 1 foot to 2 feet. We're doubling the dimensions. The volume of the original is 2,000 feet cubed, and we need to find the volume of the new. Now, these are similar solids, so we should have equivalent fractions. But let's take a look. I'm trying to compare feet, which is a line. Feet is linear. It's a line. To feet cubed, which is 3-dimensional. A line is not equal to a cube. So I need to find a way to find like units. I need to turn feet into feet cubed. I can do that. I'm going to cube this whole thing. So what I'm doing, this over here, is actually 1 times 1 times 1 feet cubed now. And this is 2 times 2 times 2 feet cubed. Well, 1 times 1 is 1 times 1 is 1. So I have 1 foot cubed. 2 times 2 is 4 times 2 is 8. 8 feet cubed is equal to 2,000 feet cubed over x. Now I have like units, feet cubed and feet cubed. Nice. So now I can cross multiply. So I've got 1x is equal to 8 times 2,000. Well, 1x is x. And 8 times 2,000 is 16,000 feet cubed. So the volume of our new tank will be equal to 16,000 cubic feet of water. Okay? So we're still using the idea of equivalent fractions. Here we had a ratio, 1 to 2. And we're still using the idea of equivalent fractions, only we need like units. So I'm going to cube this. And these need to be equivalent fractions, so we can cross multiply to find that missing measurement. So this is what we're doing today.